So today in calculus, we're going to see about integrals. And okay, so last time we saw what a integral was. So it's the area under a graph. So here we have our graph. Let's say it is x here and y over here, or f of x, doesn't matter. And we have our function. That is, I don't know, something like this. And let's say it continues forever. Okay. So the integral, let's say from here, from the point A to the point B, is just the area. Okay. And I don't know how to make a dotted line. The area from here to oh, horrible, to here. So this area over here, this is the integral from A to B of this f of x. And we would say the integral, so like this, integral of f of x, okay, from A to B. Okay, so yeah, that's it. And we could say also that f of x in this case, I don't know, be sine of e to the, actually, I don't know, like x to the e, something like that. And so yeah, that's it. I could also change this f by f of this y by f of x, but yeah, that's it. And let's say that that our f of x, let me just change colors because it's getting a little bit. Let's say that our, oh gosh, our f of x is, I don't know, x squared minus 1. It's supposed to be 2. X squared minus 1. There we go. To the 50th power times x. Okay, that's our function. And so we're going to indefinitely integrate integrate. Okay, so it's an indefinite integration of f of x, or here x squared minus 1 to the 50th power times x. We're going to be integrating in relation to x dx. We also use this notation for derivatives, like I'm going to be derivating x in relation to, I don't know, time, for example, dx dt, and we are going to use the same thing. Okay, and how do we do it? If this was a sum, it would be easy because we would do it separately. So it would be x squared minus 1 to the 51 over 51 plus x squared over 2. Okay, pretty easy. Or if the x didn't exist, it also would be pretty easy, but it is a multiplication. And at first I thought I'm just going to multiply, so it's going to be x to the 3 minus x, okay, multiplied by x, and then over here it goes to the 50. But let's just do like 3 minus 2 squared, okay, times 5, for example. So 3 minus 1 is 1, squared is 1, times 5, that's equals to 5. But if I multiply, then it's 15 minus 10 squared, which is 5 squared, which is 25, and this over here is 5. So yeah, pretty big difference. So we would have to open up these parentheses and then multiply everything by x and then do. And you have to agree that this is very hard to do. So what are we going to do? We're going to say that a variable, I'm going to choose a random name, and by coincidence it's going to be u. Okay, not u, I mean the letter u. And so we say that u is equal to x squared minus 1. Okay, and why did I do this? Because now we have u to the 50th power times x dx. But we do have the derivative of u, which is du. And we're going to derivate u in relation to dx. And we're going to find this so that we can replace, because we don't want to do du in relation to dx. We want to do u in relation to du. So dx over du, actually the contrary, the opposite, du over dx. That will be the derivative, which is 2x minus 1, but the derivative of a constant is 0, so yes, 2x. So du, that's equal to d to 2x dx. So this is a function, so you cannot just multiply dx because dx is not a number. But just for teaching sake, we're going to say that we multiplied this dx. But actually, it would make sense to say, oh, if we have an x here, we're going to be using the dx to show that we are doing in relation to x. Okay. So yeah, du is 2x dx. And here we see that we have this thing over here. So we have 2 over here. So we need to divide by 2 so that it gets the same thing. Okay. So it would be, okay, indefinite undefined undefined integral of u to the 50th power du over 2. But this is very uncommon. So what we actually do is that we multiply 1/2 du, and ta-da, here we have it. We won't be integrating this 1/2 because it's multiplying, so we just like leave you there for a moment, and then we do u to the 50. We're going to uh, integrate, so it's u to the 51 over 51. Okay, and then what we have is u to the 51 over 51 times 2. But our question is not in u. Our question is in x. So now we have to transpose it to x. It's very simple. We stated that u was equal to this. So just have to do x squared minus 1 to the 50th power, 50th, 51th, 51st power divided by 51 times 2, which is 102. Okay, so that is our answer. We had a very complicated thing over here, and now it was very easy to solve. So now we're going to do a few examples. Okay, so let me just take that book. Oh boy, something happened over here. Okay, now I'm back. So let us do a few exercises. So first, the integral of 2x squared plus 2x minus 3 raised to the 10th power multiplied by 2x to the 2x plus 1 dx. This dx over here is once more referring, saying that we are doing this integration related to x. Okay. And so yeah, another thing that is very important is that normally for us to do that substitution, the derivative of this needs to be something like this. Okay, let's say that we had like only 2x squared to the 10th power. Okay, you cannot see anything. Let me just change the color. Say okay, it's 2x, okay, times x squared, for example. I mean, if you do that, it's not good because the derivative of here would be 4x, and it does not look like x squared because you would have to multiply by x. So this does need to be a x to the first power, okay? So that the derivative would be x to the first power, both of them, right? So yeah, this is a little parenthesis. So okay, continuing. So what we're going to do, we are wisely going to choose our, I used u, but it could be any, let's say z, okay? Z is going to be 2x squared plus 2x minus 3, okay? And so it's going to be z to the 10th power times, okay, what's the derivative of z in relation to the derivative to x? That would be 4x plus 2 plus 0, okay? 4x plus 2, and we can see over here that it's 2x plus 1, so it would be 2x plus 1. So yeah, once more we have to divide by 2. So it would be the sum of 1/2 times z to the 10th power du. And so what we do then is z 11 over 2 times 11 is 22, which now we have to go back to x, would be then, my z looks like a 2. Okay, this is a z and this is a 2. Let me just change the color because they are very, 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 very similar. Okay, now I've already used that. Let's say this one. Okay, so it would be 2x squared plus 2x minus 3 okay, to the 10th, to the 11th power, raised to the 11th power, divided by 22. Okay, very, 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 very easy. Let's go to the next one, shall we? X to the 3rd power. Let me just clear this up. Okay, so clearing it up over here, and boom. We have x to the 3rd power minus 2. All of these raised to the 1/7 times x squared. And we can see over here x to the 3rd x squared the derivative of this is indeed going to be this one. Okay, so we're chilling dx and the derivative, which is an elongated s, which do make sense because actually it does make sense because it's a sum, the sum of the little rectangles below the function. Okay, okay. So we're going to wisely choose v. Okay, I'm constantly changing names just to show you that the name doesn't mean anything. I mean, yeah. Okay, x to the third minus 2. Okay, that's v. And so du, actually no, that's du, it's dv over dx. That's going to be equal to 3x squared plus 0, or just 3x squared. So x squared dx, we can see same thing over here, and we just have to multiply all these by 3, and that's equal to du. So once more, what we're going to do is say that the summatory, actually the integral of v to the 1 over 7 times 1/3 du. Okay, integrating this would be v to the 1/7 plus 1 over 1/7 plus 1 multiplied by 3 du, the summatory. Okay, and so what is 1/7 plus 1? 1 is the same thing as 1 over 1, and we could just multiply this. Okay, 7 divided by 7 is 1. 7 divided plus 1 is 7. That's the same thing as 8/7. We could even do it faster by saying that 1 over 1 is the same thing as 7 over 7, because I mean, a number divided by itself is equal to 1, and so they have the same denominators. We can sum the numerators and we get 8/7. So it's going to be summatory of v to the 8 over 7 power divided by 8 over 7 times 3. Okay, du. And so what is this? This is going to be v to the 8 square root 7. Okay, because we know that v to the 1 over 2, that's the same thing as v to the 1 square root 2. But we oftentimes we omit this 2 because square root, we don't need to put the 2. So yeah, it's this divided by 8. We leave the 8 over here, and we go to 7 up here, and so we have 7 square root 7, okay, of x cubed minus 2. Is it that? X cubed minus 2. Okay, yeah. To the 8th power. Okay. Everything divided by 8 times 3, which is 24, and that is the answer. This one was a little bit more complicated, but nothing that we cannot handle. Okay, let's go to the final one, shall we? Just erase it. So this is the substitution, which oftentimes they use the letter U, but you can use any letter you want. Okay, so now the last one. I'm going to write as it is written in the exercise, but we're going to then write it another other way. Okay, x dx over the square root of 5, or the fifth square root of x squared minus 1. And here it is kind of saying like if dx was a number, but it is not. It's kind of like a function. So like I cannot do like sine of x. Okay, let's say sine of x is equal to 30 degrees. I cannot say like divide sine by both sides and we do like 30 over sine that's equal to x. No, we need a sine of something. Okay, so we cannot just divide and multiply dx. Okay. Okay. And so what we're going to do is we're going to do x over x squared minus 1. Okay, fifth root. And we're going to multiply by, not multiply, dx. Forget this thing over here. Dx. Okay. We're going to do the summatory integral. Oof, horrible. Okay. And so let's say that a very special letter, that r is equal to x squared minus 1. Okay, so dr dx would be what? It would be 2x minus 1, or that is 0. So yeah, just 2x. Okay, and so 2x dx. And once more, we see that this is the same thing as this. So what we have to do is divide by 2. So then we have 1/2 times square root of fifth. That's the same thing as doing this. X squared minus 1. That is r. Okay. And r to the minus 1 over 5. So yeah, that is the same thing. dr. Okay. So it's going to be 1 over 2 times r to the minus 4 fifths, because we're going to do minus 1 over 5 plus 5 over 5, which is 1. Okay, so that is indeed 4 to the 4 fifths. Okay, divided by 4, multiplied by 5, because we divided by 4 fifths. That is the same thing. Okay, so it's going to be 2 times is 8, so 5 times x cubed. Well, actually 5 times 4. Oof, this is complicated. Okay, it's going to be r to the minus 4 over 5. Okay, divided by 8. 2 times 4 is 8, and multiplied by 5. So that is going to be the same thing as saying 8 over 5 times x cubed minus 2, I guess, was the thing. All of these to the 4th power. Okay. All these to the 4th power. Taking the 5th root. The 5th root multiplied by 5 and 8 above. And that's our answer.